everyone, welcome back to my channel. I am Vanshika Verma and in this video we will talk about my second question of my end semester examination of data science. So let's move to the question. The question says, what is data imputation? How would you decide on the best imputation method for handling missing values in a large data set? Discuss the potential risk of using the mean value method and explain how the nearest neighbor imputation method works. So first of all, what is data imputation? So data imputation is a process of replacing missing or incomplete value in a data set with substitute value. जो भी मिसिंग वैल्यू होती है डेटा सेट में इनकम्प्लीट वैल्यू होती है तो उसको मिसिंग वैल्यू को उस जगह पर लाने का काम करता है डेटा इम्प्यूटेशन वो एक प्रोसेस होती है. So missing value is common in real world data set and can occur due to various reasons. किसी भी तरीके से किसी भी रीजन से आ सकता है. सेंसर फेलियर की वजह से आ सकता है, यूजर नॉन रिस्पॉन्स की वजह से आ सकता है, डेटा एंट्री की एरर की वजह से आ सकता है, किसी भी वजह से आ सकता है. Imputation helps maintain the integrity of the dataset, enabling robust analysis and machine learning model training by preventing issues caused by incomplete data. So now let's see how we choose the best imputation method. So best imputation method depend on the nature of data, the extent of missingness and the analysis or model you intend to apply. So the key consideration are, सबसे पहले हम देखेंगे what kind of data we are struggling with. So it can be numerical, categorical, time series, spatial data and the pattern of missingness. किस तरीके से missingness आई हुई है, MCAR, MAR, MNAR. MCAR stands for missing completely at random. Missingness is unrelated to the data itself. जितना भी data उससे unrelated missingness है. Missing at random missingness depend on observed data but not the missing data. And the MNAR is missing not at random, so missingness depends on the missing data's value. उसके हिसाब से होती है. परसेंटेज होता है मिसिंग डेटा का. सो स्मॉल परसेंटेज ऑफ मिसिंग डेटा लेस देन 5% may be filled with simple method like mean or mode, and a larger percentage may require advanced method like multiple imputation or model based approaches. Now model and goal. If maintaining data variance is crucial, अगर crucial है maintain करना data variance को, advanced imputation method जैसे KNN, K nearest neighbor, उसको prefer करते हैं और ज़्यादा predictive model के लिए imputing with model derived value might work better. तो ये सब methods होती है data imputation की. So now move to the other part in which we have to describe the potential risk of using mean value and nearest neighbor imputation method. So the mean value imputation method replaces missing value with an average of available data for that variable. So mean means average, तो average निकालते हैं data का जितने भी variable होते हैं and that answer and value will be the missing value. Well simple and computationally efficient, एंड इसको बहुत सारे ड्रॉबैक्स है इसीलिए इसको रिस्क है इसको यूज करना. लॉस ऑफ वेरिएबिलिटी. रिप्लेसिंग मिसिंग वैल्यू विद द मीन रिड्यूसेस द वेरिएंस ऑफ द डेटा लीडिंग टू पोटेंशियल अंडर एस्टिमेशन ऑफ वेरिएबिलिटी. तो जो वेरिएंस है वो लॉस हो जाएगा कहीं ना कहीं. Now introduction to of bias. If the data is skewed, using the mean instead of median can introduce bias affecting statistical एनालिसिस. तो डेटा स्क्यू भी हो सकता है ना, तो मीन की जगह अगर मीडियन को यूज करेंगे तो अच्छा रहेगा. नाउ डिस्टोर्शन ऑफ रिलेशनशिप्स. सो imputing with a single value does not preserve relationship between variables which can mislead machine learning model. कहीं ना कहीं उनके पीछे जो रिलेशनशिप होगा एवरेज निकालने से मीन निकालने से खराब भी हो सकता है. Unrealistic substitution. Substituting the mean can create artificial value that don't realistically reflect the natural distribution of the data. आर्टिफिशियल एक वैल्यू हमारी हम बनाकर निकाल लेंगे जिसको हम हो सकता है वो कई हद तक अप्रोक्सीमेटली इक्वल हो सकती है, बट अगर वो नहीं उतनी इक्वल रही तो जो नेचुरल डिस्ट्रीब्यूशन होगा डेटा का वो खराब हो जाएगा, थोड़ा रियलिस्टिक नहीं लगेगा. Now impact on downstream analysis. So imputation using the mean may negatively impact model sensitive to variance, जैसे कि clustering और PC है. Now the second question is how the nearest neighbor imputation method works. So the working of nearest neighbor imputation, which is k nearest imputation generally, and it is says as KNN imputation method. So this imputation method replaces missing value by considering the k most similar instance, which can be says as neighbors, as the name suggests, in the dataset. It is a more sophisticated technique that takes into account the relationship between variables. So let's see the steps in nearest neighbor imputation method. First, distance calculation, in which we determine the distance, which can be Euclidean, Manhattan or cosine, between the instance with missing values and all other instances based on observed features. Now we select after it neighbor. So identify the closest neighbor with the smallest distance to the instance with missing data. So इसका सबसे कम distance रहेगा, उसको हम select करते हैं. Then impute missing value. For numerical data, the missing value is often replaced with the mean or weighted mean of the neighbor's value. And for categorical data, the mode of the neighbor's category is used. Mode को use करते हैं categorical data में. Now let's see the advantages of KNN imputation. First is preserve the relationship. In the last method we see कि relationship कहीं ना कहीं loss हो जाती है. It is flexible, which works for both numerical and categorical data, and dynamic, that adjust imputed values based on the structure of data, resulting in more realistic substitution. अभी last वाले में realistic data नहीं मिल रहा था, हमको थोड़ा artificial value मिल रही थी, तो it is dynamic also. So now let's see advantages है तो disadvantages तो होंगे ही. So first disadvantage is computationally expensive. So for large data set, calculating distance for all instance can be time intensive. Time लग सकता है हर value का distance calculate करेंगे large data set में. K के लिए sensitive होता है, so the choice of K significantly influences result. Too small a K may lead to overfitting, while too large a K may dilute the imputation quality. तो अगर जो K होगा, अगर वो बहुत ज़्यादा कम आएगा तो वो ओवरफिटिंग भी कर सकता है, और अगर बहुत ज़्यादा भी आ जाएगा तो वो डाइल्यूट भी कर सकता है क्वालिटी को. Now assume data similarity. Assume that missing value are similar to observed value is neighboring instance, which might not always be. तो हर बार थोड़ी ना सही होगा. Now let's see the comparison of mean versus K nearest neighbor imputation. So the aspect we took here is complexity, preservation of variance, sensitivity of outlier, realistic substitution, and lastly we have a handling of categorical data. So the complexity of mean imputation is simple and fast, and KNN imputation is complexity is computationally थोड़ी intensive. Preservation of variance mean imputation में poor, and KNN में good. And sensitivity to outlier mean imputation में high, KNN में low. Realistic substitution में mean imputation में low, KNN imputation में high. And the handling of categorical data, तो mean imputation में तो कोई support ही नहीं होता है, KNN में होता है support. So in the last we can say the best imputation method depend on the specific data set and the analytical goals, as we have talked about earlier. While mean imputation is straightforward, its risk make it unsuitable for nonce database or when the relationship between variable matters, and in contrast KNN imputation offer a more realistic approach by leveraging data similarity, but may be computationally expensive for very large data set. For robust result, carefully evaluate the missing data pattern and use cross validation to assess the performance of different imputation method. So this is the answer of my second question. Now we will meet you in my next video. Till then, keep smiling, keep exploring. Bye bye.